Welcome to today's VF Reminder. Today we are going to talk about high lift devices, and more about trailing edge flaps to begin. Thanks to them, we improve performances of aircraft at takeoff and landing, shorter distances to operate from a runway, so a greater payload. Maximum lift coefficient is increased by artificially improving camber. The other consequence is the reduction of the stalling angle of attack. A flap is a hinged portion of the trailing or leading edge which can be deflected to increase the camber. Let's begin with some comparison. Plain flap has a simple construction, gives a good increase of maximum lift coefficient with fairly high drag. Used at low speed where very short landing and takeoff distances are required. Split flap increases lift in the same proportion as plain flap at low angle of attack, but more important at higher one because camber is not increased. Drag is higher due to depth of the wake. Slotted and multiple slotted flaps let appear a slot or a gap when lowered. Thanks to it, higher pressure from the intrados is re-energizing the boundary layer, so the separation of the airflow is delayed on the flap's upper surface. As a result, a greater increase of maximum lift coefficient is obtained, with a lower drag, compared to plain and split flaps. Fowler flap moves rearward then down, so surface area then camber are increased. Fowler flap can be slotted. It ensures the greatest lift augmentation and the lowest drag increase, due to slot and thickness reduction, chord ratio. But, due to rearward extension of the chord, pitching moment is higher. You can keep in mind that lower flaps increases lift and drag. The higher the angle of flaps, the higher the increment of drag but the lower the increment of lift. Since lift and drag are increased, but not in the same proportion. Drag increment is greater, so lift to drag ratio is decreasing when extending flaps. Maximum ratio occurs where the tangent from the origin of the polar curve touches the curve. Lift to drag ratio measures aerodynamic efficiency and aircraft's performances, range, climb and glide angle. With flaps extended, range decreases, climb and glide angle increase. Flap movement induces a pitch moment, due to center of pressure movement combined with a downwash at the tailplane. Since the pressure distribution is modified over the whole aerofoil, and more particularly close to the flap, center of pressure moves rearward when flaps are lowered. As a consequence, a pitch down moment is created. The downwash of the wing determines the tailplane angle of attack. When flaps are lowered, this downwash increases, so the tailplane angle of attack decreases, a pitch up moment is then induced. The overall pitch moment depends on which effect is dominant. Type of flap, wing position and relative position of the tailplane influence this overall pitch moment. At constant speed with flaps lowered, lift is increased if other factors are not modified. Since weight is equal to lift, we must decrease it, by decreasing angle of attack. Therefore, with flaps lowered, a nose-down attitude has to be flown, more easier to see the runway at landing. Challenge yourself on the Instagram profile. And do not forget to subscribe if you have liked this video, so you can be advised when new ones will rise.